Madam, saya nak tanya,
Ya.
untuk kelas yang sepatutnya hari Isnin tu lab, kita orang belum isi form untuk nama group.
Saya tulis kat sini kan?
Okay, thank you, madam.
Alright. Alright, okay. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon. Okay, so today we will start a topic that forms the foundation of Java programming. Okay. Mainly it is about object oriented, and some details item that we will learn is the object and classes. These are the item that is belongs to this object oriented technology. Alright. Okay, so by the end of this lecture, we expect you to explain the object-oriented technology and the programming concept, and also apply them using diagram and Java codes. Okay. Okay, so what is the object-oriented technology? This is actually one of the field, and under this OOT in short form, there is a technical part whereby it is assessed based on the programming techniques. Okay, so this OOT is the concept based on objects rather than actions. Okay, so under this OOT, it's organized software as interacting objects, and the object-oriented programming is the practical implementations of this object-oriented technology, whereby you'll be assess the skills based on the programming language. Alright. Okay, so in short form, so OOP, object-oriented programming, focus on objects. Okay, not steps or the instructions. Okay, so basically we identify object first, then we decide how they interact. Okay, so for example, let's say we have a university system whereby it consists of students data, okay, students record. So in that situations, what objects can you think of, right? Okay, so mainly the students can be the object, and there is an actions that will be involved in this creating the object. Alright. Okay, so why we need this object-oriented programming? So remember, this is the technical skills, okay, that is under the object-oriented technology. Okay, so mainly this OOP in short form helps us to manage large programs by breaking or partition them into smaller parts. Okay, so when we have large program, basically the programs are difficult to manage. Okay, so one of the method that we can overcome or in order to solve that kinds of difficulty is to partitions that problem into a smaller parts. Alright, and it is more systematic instead of having one large program and it is very long. Okay, so when we have a program that is very long, it is not a systematic. So that's why this object-oriented programming is proposed. Okay. Now, there are two items that is important under this object-oriented programming. The first one is the object. Okay, so let's see what is the object. So mainly object is a software entity that stores the data and perform the actions. So when we talk about stores the data, means that the data will be read and it will be stored as a certain variable. So in this part, under this storing the data, we call this is as a fields. Alright, then once the data is read and stored, the next process is to perform the actions. Okay, so these actions we call as the methods. Okay, the methods. And usually we create the object with the functions for that, or similar to the functions in the problem that can create or it has a characteristic. Alright, and you need to take notes that objects are created from classes. Okay, when we create the objects, the object need to interact with each other in order to solve that kinds of problem. Okay, so the interactions will be with the class and maybe with the subclass and so on. Okay, so the current slide shows the example for the table. For example, we can sorry. Okay, let's say we have data about the student, so the object that we can create is the student object. When we have data about the bank account, so you can create the bank account as the object, right? Now, what is the characteristics, okay, or the requirement for this object? Okay, so the object must the following items. The first one, state. State means that the conditions whereby the data stored in the variables. Okay, for example, we have inputs name, age, balance, or maybe input the value. Okay, second one is the behavior. Behavior in this object means that the actions that will be performed or need to be performed. Okay, so let's say you have the data, for example the name, so the program need to read the input, or so to read this input for that types of variable of name. Okay, so we have the data name and the action is to read the input, right? Okay, then from this behavior, this object must be a unique in terms of the memory. Okay, so it means that when the user respond or provide the input, okay, during the instruction where the program asks the user to key in the input, so the program will read this input in uniquely, so it will not be read as non-unique. Okay, so that is under the third condition, which is the identity. Alright, so after this, after creating the objects, then we can create the class. Alright, okay, so a class is actually the blueprint for creating the object. Okay, so it's similar with the one that you have in the previous program. For example, we have the class scanner. Okay, so scanner is actually related to your library file. So under this class scanner, we can create objects. Let's say the object name as SC. You can create other objects, maybe scanner inputs or scanner X. Alright, so under this class, there is a fields, which is your data. There is a method, which is the behavior, and you need to take note that objects are instance of a class. It means that the class itself cannot be an object. Okay, so we have the rules to create between the class name, object name as follow. Okay, so we start with the class name and the object name. Then we have equal, okay, to the new. This is the keywords of new, and then your class name, right? Okay, so similarly for this one, please imagine that your class as the blueprint, and the object, let's say it is the something that you're going to build from the blueprint. Alright, is a class stored in a memory? Is the class stored in a memory? Can you answer my question? Is a class stored in memory?
No.
Why no?
Uh,
So why no?
because it's in the Java library.
It's a Java library. That is a library file. This is something need to be import. I mean, in the, let's say you define that public class. Okay, so is that class stored in a memory? New one. New one.
It's not stored in memory because the class itself isn't an object, and only the object would be stored in memory. The class just outlines what the object is.
Okay, basically, the class stored in memory, but it is not the same way as object. Okay.
I see.
Okay, it's stored in memory, but not in the same way as object. Okay, so basically class, we define something that we loaded into the memory when the program runs. Okay, so for example, it store the class structure and the method, the method codes, the method syntax, but it does not store the actual data values. Okay, so that is the meaning a class itself is not a real object, right? Okay, so for the object that we create, it is in the memory when we use the keyword of new. Okay, can you see the new scanner? Okay, so the object is created, so means that in this case our SC object is created in memory because there is a keyword new. Okay, there's a keyword new. So in this case it stores actual data. Here there is an actual data. Alright. Okay, so all object has its own memory space. Alright. Okay, so now we see the summary here in this table. Okay, so the class is the blueprint, but is does not represent the actual data. Okay, then it contains logical structure. This no memory allocated here in terms of the actual data. This one, no memory allocated. This one is in terms of the actual data. Okay, when there is no inputs readed. Alright. Okay, so take notes. This no memory allocated it is for the actual data. Okay. Alright, so okay, basically you can have one class with many objects. Okay, for example, you have one public class, but you can use many objects under this class. Okay. Okay, so example of concept we haven't go through yet with the actual coding actually. Okay, so let's say we have this case of class name of the students. Under this class name, it contains some attributes which is your fields, okay, such as the name, metric number, CGPA, and it can contain the following actions such as to register course, calculate CGPA. Okay, so in this case, each student object has different values but same structure. Okay, so now let's look at the fields, okay, in details. Okay, fields or the instance variables. Some authors in reference textbook call this as the instance variable. Okay, so fields actually store the object data. Okay, so does each object have its own copy of fields? Anyone can answer? Does each object, let's say you have object, maybe object 1, or maybe it can contains 2 object in that class. Okay, does each object has have its own copy of fields?
Yeah.
Why? Why yes?
Because
Because
each object will inherit a separate field from the class.
Each object. Okay, yes, the answer is correct, alright? Okay, so basically when the class is defined, okay, it only describe what fields that is exist, okay? So when the object is created using the keywords of new, so memory is allocated or stored for that object. Then each object gets its own separate copy of all fields, okay, or these instance variables, alright? Alright, okay, next one is these methods. Okay, so please do not be confused with the terms with Java methods. This one is methods in your object-oriented programming. Okay, so basically these methods define what an object can do. Okay, for example, let's say we have this coding. Okay, let's say we have this coding next int, next int. Okay, so these kinds of methods, what is the functions? Sc is your object. Okay, these kinds of methods we call as the behavior for this object sc. Okay, same goes like this one, rand rands, and str referring to the string. Okay, so these methods actually will have some return values, and it can be called with this using object name. Okay, this is the methods. Alright, next one is the constructors. Okay, so constructors is okay, constructor is the special method used to initialize the objects. Okay, like this one, this is the one that you are familiar with. Okay, so it is defined by the same name as the class. Okay, same name as the class, and it will be executed when an object is created. Okay, so this is a part of the coding. So when you have some kinds of scanner sc equal to this line, okay, so the whole things will define the fields, constructors, and so on. Alright. Okay, so these are some common objects in Java based on the standard library file. I think you have seen maybe scanner class, string class, and JOption paint. Alright. So this object is in Java. This is example for predefined classes that programmers can directly use. Okay. So we can create new classes actually. Okay, but scanner, this string, JOption paint, the class is actually has been created. So so we just call these kinds of classes in order to use that. Okay, so some common functions for scanner is to read input from keyboard. String is store and manipulate the text. And for JOption paint, this is something that we work with GUI input or output dialogues. Alright. Okay, so here we have scanner as the object. So this scanner object is belongs to this java.util package. Okay, so usually we have the coding such as import java.util.scanner. Alright, so java.util is the one of the package that is available in Java. Right, so many use example to read the integers, double, float, or string. Okay, next one we have random object. This is actually one of the object that is commonly used to generate random numbers. Okay, when we have problems, something like game simulations or testing, or maybe we want the program to generate random numbers between 1 to 6 in order to calculate the probability, or maybe the problem is related to dice rolling. Alright, so we can call these random functions, okay, based on the object. Okay, next is the string. Okay, so string object represents text. Okay, the one that commonly used under this string object is to find out the length or convert the input to uppercase. Okay, and also equals. So if you want to use these kinds of methods, so you can use this string dot something, right? Okay, so it is something that you need to take notes that we can create more than one object in one class. Okay, so the purpose of this creating multiple objects. Multiple object means that you have more than one object in one class. Okay, the purpose of creating this multiple objects so that your program can have different functions and methods that is available, that you can work with different methods, okay, across different methods. Mainly these multiple objects work when you have same structure but it is different data. Okay, for example, we have this scanner SC1, SC2. So SC1 and SC2 is your objects. In this case, you have two objects. Okay, next one we have random R1, R2. So R1 and R2 here is your objects. Okay, now in general concept of this object-oriented technology, okay, so all the items that you have seen before, such as your fields, object classes, and so on, following these four fundamental concepts. Okay, those items are under this four process. First one is the encapsulation, second is the abstractions, third is the inheritance, fourth is the polymorphism. Right, so these four concepts work, okay, for the purpose of to secure the programs or to reuse the code for a certain reason, and for flexibility in terms of the scalability. Alright, okay, so what is the encapsulations? So it is involved of working with bundling data when you have big data and methods into one unit. So this unit we call as the class. Okay, but in this under encapsulation process, the data basically is hidden from outside access. Okay, and the access is actually controlled using the methods. The purpose here, we want to set either something is public or private, which is to protect the data and to prevent any data leakage, okay, or any modifications on the data. Alright, so if you want to protect the data, so there's a keyword that you need to apply for between the access, okay, between the methods and also the class and so on. Okay. Okay, so for accessing in terms of methods, you can define what kinds of method that you want to access it. Also, there are different items or method that is applicable to control the access, right? Okay, now under this encapsulations, we have this Unified Modeling Language Diagram, okay, or in short form as UML. Alright. Okay, so this UML diagram help us design before we work with the coding. Okay, so under this UML diagram, there are three phases. The first one is the class name. Second one is about your attributes, which is your data or the fields. Third one is the method. So this method involves the operation. Okay, so the first top is the class name, for example. The middle one is the attributes. The third one is the bottom. Okay, so in this diagram, there is a special symbols that we apply to indicate this access level. Okay, symbols in the diagram such as plus. Plus means public, right? Minus symbol means private, and we have compounds or the hashtag symbol means protected. Okay, so these three symbols show the access level, right? Okay, so this is the example. Okay, so basically we can work with this UML diagram before converted the problems into the Java codes. Okay, let's say we have the class name rectangle. Alright, the attributes, in order maybe the problems or the situations are related to the rectangle is to calculate the area. So in order to calculate the area, we need the informations about the data of width and the length, right? Okay, so your data, which is your attributes, is the width, which is in the decimal numbers. Okay, let's say we choose as double data type, and same goes for the length. Alright, so what are the methods or operations related to this rectangle? So maybe we want to set the width value and the length value. Okay, let's call the functions or the method name as set width and set length accordingly. Alright, okay, so we can have other functions such as get the width value or maybe get the length value. Okay, let's say the method name as get width and get length. Alright, and then we have another method which is the operation such as to get the area value. Okay, but this get area means that it's something that involves the calculation. Alright, so the figure on the right here represent your UML diagram. Okay, okay, so the first one is your class name. Okay, so the first level here, so in this diagram show just a rectangle, this which is the class name. Okay, then second level is the attributes. Okay, so we can see here there is minus symbols, right, for the width and length, right? The data type as the double. Okay, so minus means that we want to protect. Okay, because we want to set the data as private. Okay, so private means that the data can only be accessed, okay, within that structure, right? Okay, then we have plus for your set width, set length, get width, get length, and get area. Alright, so these are the public. Public means that when we have many methods here, alright, so each methods or in the structure can access, okay, the variables, okay, involved across the structure, across these methods, because it's set as the public, right? Okay, so these are the transformation from your UML to the Java coding. Okay, alright, so this first level is your class name rectangle. Okay, so in the coding we have public class rectangle. Alright, so next level is your width and length. Okay, so this is private one, right? So in the coding we state here as private double width and length. Alright, okay, next we have the following methods such as the set width, set length, okay, until the get area. So it is public. You can see the keywords here, public. Alright, so any methods that involve the operations are stated clearly as follow, right? So the first method, which is set width, So this is to set the width as W. Okay, next one, second method such as set length. We want to set the length as length. Right, next one we have get width. So this is to return the width value. And the methods of get length, this is to return the length value. And we have get area. This is to return the computed area such as length times the width. Alright, so this is the transformations between your UML to the Java codes. Okay, so next one, this is the second concept after the encapsulation, which is the abstractions. Wait, something. Okay, second process is the abstraction. So these abstractions focus on essential details and it will hide internal implementations. Okay, so mainly in the second phase, it's focused on what an object does, but not how. Okay, for example, let's say we have the real case such as in the ATM machine situations, the user knows how to withdraw but does not know the internal process, how these ATM machines work. Okay, for examples. Okay, so the following coding shows the abstractions process. Abstractions. Okay, so let's say we analyze the given codes. We have class name of abstractions demo, right? Then we have the main methods. Okay, next one we have abstract class shape. So the keyword here is the abstract. Okay, and then under this shape methods for this abstract class, okay, this abstract class will get area, called the get area methods. Basically there's no other functions work under this shape structure. Okay, and then you can see here when the next structure has the class rectangle extends shape. Okay, extend shape means that we want to create subclass from your abstract class. Your abstract class name is shape. Okay, so this is the example of the abstractions, right? So basically in this shape, okay, it cannot create object. Okay, it cannot create object. So in this get area is your abstract, so there's no implementations. Alright, so under this rectangle, okay, so we have extend shape, so this is actually the subclass. So in this rectangle it must implement get area. Okay, so in this rectangle structure it must implement the get area. Okay, then we have the main structure. So in this main structure it use the subclass object. Okay, in the main structure here it use the subclass object. Alright, because why? Because in the abstract class it cannot create object. Okay, so get area is the abstract but there is no implementations. Okay, so basically your implementation is in this subclass. Right, you can see here. So this is the implementations. Okay, so this is example for the second concept, which is the abstraction. Okay, third one is the inheritance. Okay, any questions so far? Any questions so far before I proceed?
No, madam.
Okay,
No, madam.
the third one, inheritance, allows reuse of code. Okay, allow reuse of code. Inheritance in this allows that one class to be inherited properties of another. Alright, and it provides statements such as is a relationship. Okay, something like when we have persons as class, so you have details of that person. For example, student 1 is a what? Okay, student 2 is a what? So there is a relation between your class and the and inheritance. Okay, let's say your class is vehicle, it can form relationships such as your car is a BMW. Okay, maybe car 1 is a BMW, car 2 is a Pro 2 and so on. Alright. Okay, so this is example for this inheritance. Okay, let's say we have the persons, we have the students. So students extends the persons. Okay, so let's say your class name is the person, and the students in these kinds of coding, in this example of coding, the student inherits attribute name. Okay, this one, and the method display name, these things. Alright, so this is the class name, and we have these kinds of protecteds. What kinds of these protecteds? What is the meaning of these protecteds in your from your UML diagram? What is the meaning of protected? What is the meaning of your protected?
It can only be accessed by the superclass and any class that inherits it.
Okay, correct. Okay, so when you want to use that keywords of public or private or can be protected, so just use that keyword in front. Okay, so for this current coding, it shows that we have the students inherits the student's name and also the method. So the name is actually your data. Okay, so we call it as the attribute also, and display name is your method. Alright. Okay, the fourth one is the polymorphisms. This term is applicable when you have same method name but you want to create a different behavior or operations. Okay. Okay, for example, let's say we have method of calculate fee, and under this calculate fee you want to create different operations such as undergraduate calculations and also postgraduate calculations. Okay, so it means that you have one method but it have different operations. Okay, this operation we call as the behavior. Okay, let's see these kinds of examples. Okay, so this coding do not have any computations. Okay, so we have the class name of polymorphism, simple, and we have main methods here. Alright, so under these main methods we have calling methods such as new cat, new dog. Alright. Okay, and we have the class animal. So this class animal is your super class. Okay, inside this class animal, it contains sound, which is your method name. Alright. Okay, next one we have class cat extends animal and also class dog extend animal. Okay, basically this class cat and dog override the same method. Okay, override the same method means that just now your super class is animal. Alright. Okay, so we have one method which is your animal, but because that this animal is called in the main method. Alright, so same method called as A1 and A2. Okay, A1 and A2. Okay, so but we can see that when these methods call A1, animal A1 and animal A2 is called in this main method, the class cat extend animal and also class dog extend animal, it contains different outputs. Okay, different output. Okay, so same method call such as A1 A1 dot sounds and also A2 dot sound. Okay, for example, different output will be produced. So this is example of polymorphism. Okay, same method is called but it contains different outputs. Right. Okay, so this override confirms the intentions, okay, of this override. Okay, so in summary for these benefits of object-oriented technology, it works with modular programs because you can generate different class and methods. It can reuse codes easier to debug the program, and you can have different data involved in the program, so requires different collaborations and can be expanded, okay, for larger systems. Alright, so this is a summary of the one that I have explained. Okay. Okay, any questions so far? Any questions?
No media.
Okay, so under object-oriented technology, we have items such as OOP. Okay, so it's involve classes and object. So what you should know about class and object? So class is the blueprint. Okay, contains the attributes and methods, and objects is the instance of a class created in the memory. And object have states, behavior, and identity. So this must be unique. Common Java objects that you have used is the scanner, the string, and also J option pin. Alright, so for the attributes and methods, you need to differentiate what is the meaning or difference for these attributes. So these attributes store the object data. Methods defines the object behavior or the operations, and objects are created using new keywords. Using this new. Alright. And then we have 4 processes under object-oriented programming. The first one is the encapsulation. So it is involve the UML diagram. Okay, so what is the UML diagram? It is visual representations that has a level such as the class, attributes, and methods. And then we have access modifiers such as the class access based on the public or default keywords. And then for the attribute and methods, we can have public, private, default, and the protected keywords. Alright. Okay, so package is something that involve with okay, for example, we have scanner. Okay, scan as the object. So in order to use that, so we need to use java.util. So java.util is the package for your scanner. Alright, then we have the inheritance, whereby in this phase allows a class to reuse another class features using the keywords of extents. Alright. Okay. Okay, this is okay, so I will provide to you a simple question for you to test your understanding for today's topic. Alright. You can pause the answer in the chat. Okay, so which statement best describe object-oriented programming? What is your answer for this question? Okay, C is the correct answer. Programming based on classes and object. Okay, question number 2. A class is best described as what? Okay, a blueprint for creating objects. Right, it's correct. Okay, next one. Number 3. What is the object and objects term? Okay, it's instance of a class, right? Correct. Okay, number 4. Keyword used to create an object. Keyword used to create an object. A new, right? Alright, next one. Number 5. Which one is a common predefined Java class? Predefined means that it has been created by other programmer. So that's the meaning. Okay. Predefined means that the object has been created by other programmers. Okay, so correct answer is a scanner, right? Okay, number 6. What does a UML represent? Okay, contain this one, your levels, class, attributes, and methods. Okay, class, attributes, and method. Okay, number 7. See number 7. Okay, what's the meaning of minus? Minus. Right, so it's a private. Okay. Okay, number 8. Okay, this one is access modifier. Okay, allows a variable to be accessed only within the same class. Within the same class. Okay, keywords is this one, private. Number 9. Okay, access modifier. Okay, used for attributes. Okay, with the encapsulation. Number 9 says, I haven't see the answer from you guys. It says protected. Please post your answer. Looks like I don't receive any response. Let me check. Let me check. Okay, I think less number of students, but others students, what do you do? No response at all. Is
Madam,
just
everyone
same
is
students
chatting?
only respond.
Oh.
Okay, let me check. Let me check the response for the students. Wait, because I need to change device first. Count. Kenapa Amir Hakim with your Wi-Fi? Number 9, most of you answer C. C, C, C. C, is it C? C and B. C and B. But mainly all answers C. Okay, but few students answer B. But correct answer for this is B, private. Okay, private. Most commonly, because here stated most commonly used. Okay, declared as private. Private due to we want to prevent the access from outside the class. Okay, prevent direct access from outside the class. Most commonly used. Alright, next one. Encapsulation. Encapsulation. This one is in the slide. Type your answer. Post your answer. Okay, correct answer is B, hiding data and control access. This one is in the first under object oriented programming. Okay, encapsulations, the first phase, first process. Okay, number 11. Inheritance. So what is the keyword? Keyword. Keyword means that it is in the coding. Okay. Keyword means it's in the coding. We don't have coding inherit. We don't have coding inherit. Okay, inheritance, the syntax. Okay, for the inheritance, the keyword of extends. Okay, extends. Right. Question 12. Relationship for inheritance. Okay, is a. Alright, is a. Correct. 13. Keyword to create abstract class. Okay, keyword means that the syntax to create an abstract class. Okay, correct one is abstract. Alright, abstract, not override. Okay, abstract. Okay, next one for polymorphism. Polymorphism. Okay, correct answer, same method name with different behavior. Okay, same method name with different behavior. Alright. Okay, next one, override. Override. If you see this override in the example that I provide to you in the slide just now, coding example. Why is a loop? It's not why. It's not loop, not loop. Loop is for loop, right? It's meaning of override. Okay, it's annotations. Annotation means as a remark or a comment that we do in the program. Okay, annotations. Alright. Okay. So I'll be sharing for today's attendance. Start with MIT students.
Ada nak manual?
Nama.
Julita.
Okay, thank you, madam.
Alright. Okay. For group B04, please the group leader contact me after this. Nama awak ada Nor kan? Sekejap. Nor Julita
Nur
ke?
Julita.
Itu, sekejap. Okay.
Terima kasih, madam.
Okay, madam. Terima kasih, madam.
Alright.
Thank you, madam.
Thank you, madam.
Madam, may I have manual also?
Why you cannot scan?
I still
you,
haven't
madam.
found my phone at home. I'm on my laptop.
Okay. Alright. No more.
Madam, you put
Yeah.
my attendance?
Yeah, correct.
Thank you, madam.
Thank you, madam.
Dana. Alright. Okay, group leader from B04, please message me in Teams. Okay, for you B students, this is the QR code.
Thank you, madam.
Alright.
Madam nak manual?
You mana daripada?
Yang
Ubit
tadi madam.
Medium expired.
expired. Sepatutnya boleh lah. Kenapa tak boleh scan
Medium expired.
Okey, Ahmad Afandi ada? Saya panggil nama.
Ada madam.
Aisyah Ilman,
Ada medium.
Amirul Hafiz, Amirul Hafiz,
Ada madam.
Ibrahim Hassan,
Ada madam.
Khairul Hazim,
Ada madam.
Muhammad Nur Ehsan,
Ada madam.
Muhammad Ashraf,
madam.
Zulkifli,
Ada.
Ashraf Daniel, Muhammad Daniel Hakimi,
Ada madam.
Muhammad Haziq Ikhwan,
Ada madam.
Nur Aida Iwani,
Ada madam.
Nur Madina,
Saya.
Nur Ain Farzana, Nurin Ilyana,
Saya doktor.
Siti Nordiana,
Saya doktor.
Syabil Aimar. Okey, okey. MIT students tadi siapa? Nama?
Thank you, madam.
Right.
Thank you, madam.
Thank you madam. Madam, kalau annual juga.
Soal tadi. Madam, tolong.
Tanya madam.
Nama saya Nur Ain Zulaika.
Madam.
Lagi siapa
Tanya.
ada issue attendance? Tanya kejap, saya nak settle attendance dulu